On the axes below, sketch the graph of y equals tan 2x for negative 2 pi to 2 pi. So if I put 2 pi here and negative 2 pi over here, then that's pi is about there, negative pi is about here, and then pi by 2, 3 pi by 2, negative pi by 2, negative 3 pi by 2. Now, if it's just the ordinary tan x graph, we know that the first vertical asymptote is at pi by 2. But this is a 2x, so that's going to be a horizontal dilation scale factor of half, and that means the first one will be at pi by 4. On the standard graph, the second one is at 3 pi by 2, so that's going to come over to 3 pi by 4, and now we can see where all the asymptotes are, because it's just a repeated pattern. So we can see there's going to be one here, at negative pi by 4, there's going to be one here, there's going to be one here, and there's going to be one here. Now, tan of 0 is 0, and we know what the tan looks like. So it's going to come up here, through here, and then off up there. And that's just going to repeat. So it's going to just do that, and it's going to do that, and that, and this bit will just come to here. And then the same sort of thing over here. I should probably be trying to be a bit neater than I am. But we've got the major features on there. We've got the zeros, we've got the asymptotes. And then this one will just be that bit, like so. We now want to state the number of solutions for tan 2x is negative root 3 for x between negative 2 pi and 2 pi. So if we just say that negative root 3 is about here, and put on here the line y equals negative root 3, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8 solutions. So there are 8 solutions. We want to solve tan 2x is negative root 3 for x between negative pi and pi. Since we're solving initially for 2x, we should go between negative 2 pi and 2 pi. The principal value for 2x will be the inverse tangent of negative root 3. And if we think about that one, it's going to be down here, and this angle here would be pi by 3, so it's going to be negative pi by 3. The secondary angle would be up here, with this angle being pi by 3. So, starting at negative 2 pi, which is here, we come forward. So from negative 2 pi, we come forward 2 pi by 3. So that's negative 6 pi by 3, add 2 pi by 3, which is negative 4 pi by 3. So negative 4 pi by 3. Then the next one that we reach is the negative pi by 3 that we had as the principal angle. And then the next one is going to be the next time we get to here. Well, that will be 2 pi by 3. And then the final one is pi by 3 before we get to 2 pi. So 2 pi take away pi by 3. 6 pi by 3 take away pi by 3 is 5 pi by 3. So then our final one, the answers for x, is just going to be negative 4 pi by 6, or negative 2 pi by 3, negative pi by 6, 2 pi by 6, which we can write, of course, as pi by 3, and 5 pi by 6. Find the general solution to the equation tan 2x is negative root 3. Give your answer in exact form. Well, if we think about just the principal value of negative pi by 3, this is for 2x, and then we add n pi, where n is an integer. And we can see that on here. There's our principal value down here, and then as we go around, we just meet a solution every pi radians, or 180 degrees. So just divide through by 2. So that's negative pi by 6 plus n pi by 2, where n is an integer.